Alright, welcome to the AI Research Roundup. I am your host, Alex. Today is June 6, 2025. We're looking at a paper from Hugging Face's trending list, published just 2 days ago. AMBIC, Dataset of Ambiguous Tasks in Kitchen Environment. This paper introduces AMBIC, that's AMBIK, for Ambiguous Tasks in Kitchen Environment, a new, fully textual dataset. It aims to benchmark how large language models in embodied agents like robots detect ambiguous instructions in a kitchen setting. It offers 1,000 task pairs, ambiguous and clear, with environment details, to standardize comparison of detection methods. Alright, so diving deeper into how AMBIC structures these tasks. This first figure illustrates its 3 main ambiguity types. First, preferences, where the robot should ask. Second, common sense knowledge, where it should resolve the ambiguity itself. And third, safety, where it also resolves, but mistakes are costly. These categories are vital for the benchmarks, which use metrics like intent coverage rate, or ICR. This intent coverage rate measures if the robot fulfills the user's true intention. Another is correct help rate, or CHR, which assesses if it appropriately asks for help. So to really see where AMBIC fits in, this table compares it with other datasets focusing on ambiguous natural language instructions, or NLI. These natural language instructions are just commands given in everyday human language, like you'd speak to a helper. AMBIC stands out with 2,000 household tasks and 1,000 ambiguous instructions. Plus, it features those multiple ambiguity types we just discussed, and uniquely includes clarification questions. This makes it usable as a comprehensive textual benchmark, unlike others shown here, like NoNo, SAGC, and SIF. Okay, so moving on to how these methods actually perform. These next charts visualize the intent coverage rate. This is shown across the different task types: unambiguous, and then the ambiguous ones like preferences, common sense, and safety. We see results for several detection methods, including 3 based on conformal prediction. That's NoNo, LAP, and low-free CP. Conformal prediction is a technique allowing models to quantify their uncertainty by providing a set of possible correct actions. There is also a binary baseline. The no-help method, by the way, scored 0 on intent coverage rate, so it's not even plotted here. Overall, the rates are quite low, especially for ambiguous tasks, highlighting the challenge AMBIC presents. So after seeing how current methods struggle, this table gives us a closer look at the AMBIC dataset structure, detailing what makes up each task entry. We see components like environment descriptions, the ambiguous instruction paired with a clear one, and importantly, the specific ambiguity type, for example, whether it's a preferences issue. The dataset also includes clarifying questions, answers, and multi-step plans for both ambiguous and unambiguous scenarios. This comprehensive setup is vital for AMBIC to function as a challenging benchmark for ambiguity detection. Alright, building on that dataset structure, this table now presents the correct help rate alongside the help rate. The help rate simply tells us how often a model actually asks for help. We see these rates for various methods like NoNo and low-free CP when paired with different large language models such as GPT-4 and Llama 3. Looking at the correct help rate column, the values are often stuck at either 0 or 1 across the different ambiguity types. This really highlights that current systems find it very difficult to appropriately decide when they should seek clarification. So to understand why that correct help rate is so tricky, this next table breaks down the different types of ambiguous tasks in the AMBIC dataset. It outlines 3 main categories: preferences, safety, and common sense knowledge. For each, it details what knowledge is needed for disambiguation, like the user's unique desires for preferences or general world knowledge for safety. Crucially, it also describes the ideal behavior for a good model. For example, it should always ask for clarification with preferences, but usually not for safety or common sense tasks. This variation is precisely why models struggle. So, wrapping things up on AMBIC, it's clear this new dataset really pushes current LLMs and ambiguity detection methods to their limits. A key takeaway is that models struggle significantly with deciding when to ask for clarification, as shown by those very low correct help rates. And their overall success in fulfilling the user's intent or intent coverage rate also suffers, especially with ambiguous instructions. This work suggests that LLM logits, those raw scores models use internally, might not be the best for judging uncertainty. Ambiq really sets the stage for future improvements in this area. That's all for this AI Research Roundup. Thanks for tuning in.